In the group of non-zero rational numbers, under the binary operation, this given by A with binary operation B is equal to AB by 3, the inverse of 9 is. To find inverse of this element 9, first we should know about what is the identity of this group. This group is of Q and this Q is non-zero, so exclude 0, and with this binary operation this forms group, and binary operation on two elements is defined as AB by 3. So we are seeking what is the identity element. So consider E is the identity element. So it will return A, and A is non-zero. So by the property of defining AE by 3 is equal to A, and this implies AE by 3 minus A is 0. This implies that take common because of these equation in rational numbers, so we can take common. Here this is no property of group is applying here. This is simple equation in rational numbers, so we can take common. A by 3 minus 1 is equal to 0, and this is non-zero, so E by 3 minus 1 is 0. This implies that E equal to 3, means identity element is 3. Now find inverse of 9. To find inverse of 9, consider this is an element of the group as a set of non-zero rational number, and this is binary operation. Its inverse is element A. So on operating these two elements, it will return identity, and identity is nothing, 3. So 9 into A divided by 3 by the defining property on element with binary operation, this will return 3. It means that because of these are only rationals, so we can transpose and apply mathematical operation here. So A is 1. So inverse of 9 is 1, means option A is correct. The number of elements of order 5 in the group Z15 cross Z5. It means we are seeking elements of order 5. Means if an element AB in Z15 cross Z5, then its order must be 5, and order of direct product of an element is by LCM of individual order, means order of A, order of B, and A and B are coming from, this A is coming from Z15 and B is coming from Z5. So possibility of to make order 5 is LCM either 1 and 5, 5 1, 5 1, LCM 5 5, and LCM, I think these are the possibility. And we know that an element of order D in Zn is by phi d if D divides n, means 5 divides 15 and 5 divides 5. So order of D in Zn is phi d, otherwise 0 if D doesn't divide n. It means if in first case order of A is 1, it means that only identity element of order 1 exist. So pos one element here and 5 means 5D. There are 4 elements. 1 and 4 total element is 1 into 4 means 4 elements from here, or possibility of 4 elements. In this case, possibility of an element having order 5 or 5D means 4 element into this is from element B, and this is nothing identity element. So 4 into 1 again 4, and this is 4 into 4 means 16 elements. So 16 plus 4 plus 4, there are 24 elements have order 5. How to find order of elements having 5 order in Z15 into Z5? Because of element of order from direct product is LCM of individual orders, and the possibility to check how many elements of order in Z15 or Z5 have order 1, 5 and 5. Using this fact, we find the solution, so option B is correct. The total number of surjective group homomorphism from the group Z20 to Z8. We know that number of group homomorphism, if F is a group homomorphism from Z20 to Z8, then we are seeking number we normally denote by hash symbol. This is number of surjective group homomorphism. We are seeking this one. If F is a group homomorphism from Zm to Zn, then number of 1 group homomorphism can be found by Euler-Toten function phi m if m divides n, and number of onto group homomorphism can be found by phi n if n divides m. There is no 1 group homomorphism if m doesn't divide n. Also, there is no onto group homomorphism if n doesn't divide m. This is the basic concept. So we are seeking surjective group homomorphism. It means that should be 1 and onto. It means that there is no onto group homomorphism because of 8 doesn't divide 20. So there is no onto group homomorphism. It means no surjective group homomorphism. So answer is mathematically option B. Let ZO plus be a group if the binary operation O plus is defined by if two elements A and B are coming from integer, then if we operate with this binary operation, then this give you A plus B minus 5 for all AB which are coming from set of integer. Now we are interesting to find identity element of this group. ZO plus is a group and identity is unknown here. Then the property of identity, if an element, this is an element of the group, if A belongs to ZO plus, then A E is A. This is the property of identity, and there is nothing in this A and E. It means binary operation, and by the property of this or defining, this is A plus E minus 5 is A. Now this is the equation because of A, this A and E are elements of integer. So this is equation in terms of integer. So you can cancel out, otherwise you cannot, because of Cancellation law hold whenever you can operate with inverse element of that. But we cancel out this by, as normally we do in calculation of just as in mathematics, because of these are integer. So minus e minus 5 is 0. This implies that a is 5. Means identity is 5. So option D is correct. The group S3 cross S3 has an element of order, means possible order of an element which is in S3 cross S3. What? We know that this is a direct product of finite groups of finite product. In this, the order of an element in a direct product of a finite number of finite groups is the LCM of the components of the element. LCM of the components of the elements of this is equal to order of an element G1, G2 and so on up to Gn. If this is an element, then order of this element is LCM of individual or component order of the components. We know that S3 has elements of order 1, 2, 3. So S3 cross S3 will have element. Suppose this is an element AB, then order of this element AB will be LCM of possible order of A and possible order of B. We know that possible order of A and B are means 1, 2 and 3 means 1, 1 LCM of this one, LCM of 1, 2, LCM of 1, 3 and 3 other pair also, LCM of 3, 1, LCM of 3, 2 and LCM of 3, 3. If and LCM of 2, 3, LCM of 1, 2 is done. If some LCM is remain, then you can justify yourself. But you can check here all LCM is either 1, 2, 3 and 6. None other than these LCMs. So possible order of this one element is 6. So option D is correct. LCM of an element which is in direct product of S3 cross S3 never be 18, 18, 9 and other. So option D is correct.